Alright guys, let's go ahead and jump right in. This is lesson number 1, atoms and their composition. As you know, chemistry is primarily founded upon atoms and elements. Atoms are what everything is composed of. Everything that takes up space, everything that has a physical form, it's made out of atoms. Now there are various types of atoms. Elements. You can think of elements as different kinds of atoms. Now each element has its own property and different atomic numbers, atomic weights, mass numbers, things like that. So they have their own properties. Now, the way that you represent an element when you're writing it down is by its chemical symbol. For example, let's look at the element Na. Na. That's sodium. That's the chemical name. So Na represents sodium. If you're going to write down sodium on a test, or for a chemical reaction or whatever, you don't want to write down a whole page of different names. If it's a reaction, you don't want to write down a whole page of different chemical names. It's easier to represent them as symbols. Na is a symbol for sodium. We only have one Na here, so that represents one atom of Na. Now, all atoms are composed of three things. They are composed of protons, electrons, and neutrons. Protons have a positive charge, electrons have a negative charge, and neutrons have no charge. They're neutral. Now, a positive and a negative will cancel out. So if you have an atom with one electron and one proton, that means it has no charge because you have a positive one and a negative one. Put those two things together and you get 0. Therefore, it has no charge. Now, the sodium that we're looking at, there's nothing written over here. That means it has no charge. That means that the number of electrons is equal to the number of protons in this atom. So now let's look at two things. All elements have a mass number and an atomic number. The mass number for sodium is 23. You can tell this by looking at your periodic table of elements. If you look at the periodic table of elements, it's 22.990. I'm estimating this to 23. Now, also shown on the periodic table of elements is the atomic number, which is 11. Let's write it over here. This is the conventional way to write it. So now let's look at this. This is the mass number. So what is the mass number? The mass number is the addition or the sum of an element's protons, plus neutrons. Now the reason that you don't account for electrons is because electrons are very small. They don't take up a lot of space. They're insignificant, so you don't count that when you're counting the total mass of sodium. So that's the mass number, the total mass of sodium. This is the atomic number. Elements are organized by their atomic number. The atomic number is equal to the number of protons. Number of protons. So if you have 11 as your atomic number, that means there are 11 protons in sodium. In this one atom of sodium, there are 11 protons. Let's go ahead and write that down. 11 protons. This. Now, remember what I said. The number of protons must equal the number of electrons if the charge is 0. So, we must have 11 electrons. Now, if I tell you to calculate the number of neutrons, let me show you how to do it. Because the mass number is the number of protons plus neutrons, all you have to do is minus the mass number by the atomic number. That should give you the number of neutrons. So let's do 23 minus 11. You get 12. So that means that there are 12 neutrons. If you want to check if that's right, all you do is add the number of neutrons to the number of protons, and that should equal the mass number, because that's what the mass number is. So 12 plus 11 is in D23. Therefore, you have 12 neutrons. And there you go, we just analyzed an atom of sodium. The mass number, protons, protons, neutrons, atomic number, number of protons, chemical symbol, chemical name, and here you go, all that, the protons, electrons, and neutrons. Electrons equals protons when the charge is 0. If the charge was -1, there would be one more electron because electrons have a -1 charge. We'll talk more about that later. So we cover all the basics of an atom, and there you go. That's lesson 1.